Welcome back. In this video, we're going to look at examples of converting from polar equations to rectangular equations and vice versa. Let's get to it. All right, so here's our first example. We want to convert the polar equation to rectangular form. And our polar equation is r equals the square root of 13. Now you'll notice on the side here, I have our conversion formulas, or the conversion equations that we are going to use to convert between polar equations and rectangular equations and vice versa. We have x equals r times cosine theta, y equals r times sine theta, r squared equals x squared plus y squared, and tangent theta equals y divided by x. If you want to know where these formulas come from and why they work, feel free to check out my lesson video on this topic where I cover that in more detail. All right, but for this video, we're just going to be focusing on doing the actual converting between polar and rectangular. And in this case, we have r equals the square root of 13, which only involves r. And when you have a polar equation that only involves r, not r and theta, like some polar equations will, you want to use this equation right here that only involves r and x and y. You don't want to use a formula that involves theta. All right, and so if we use this equation, r squared equals x squared plus y squared, let's write that down. R squared is equal to x squared plus y squared. We can replace r with the square root of 13, and that will give us an equation in rectangular form that corresponds to this polar equation. So we'll have the square root of 13 squared is equal to x squared plus y squared. And now if we square the square root of 13, that's just going to give us 13. So we'll have 13 is equal to x squared plus y squared. That is the rectangular form of this polar equation. All right, so here's our next example. We once again want to convert the polar equation to rectangular form. We have theta equals pi divided by 6 this time. And when you have a polar equation that only involves theta, you want to use this conversion formula right here. Tangent theta equals y divided by x. All right, because this formula only involves theta and not r, it makes sense to use this for a polar equation that doesn't have r in it either. So if we use this equation, we'll have tangent theta is equal to y divided by x. We can replace this theta with pi divided by 6. And so if we do that, we'll have tangent of pi divided by 6 is equal to y divided by x. Now, tangent of pi divided by 6 is equal to the square root of 3 divided by 3. So we'll have the square root of 3 divided by 3 is equal to y divided by x. And then just to make our rectangular equation a little bit nicer to look at, I'm going to solve for y by multiplying both sides by x. And if we do that, we will have that y is equal to the square root of 3 divided by 3 times x. That is the rectangular form of this polar equation. All right, next up, we want to convert this polar equation to rectangular form. It's very similar to what we just converted in the previous example. This time we have theta is equal to pi divided by 2 rather than theta is equal to pi divided by 6. And so since this polar equation only involves theta, we know that we want to use this conversion formula. Tangent theta is equal to y divided by x. So let's write that down. We'll have tangent theta is equal to y divided by x. And now if we replace theta with pi divided by 2, that will give us our rectangular equation. So we'll have tangent of pi divided by 2, and that is equal to y divided by x. All right, now to simplify, tangent of pi divided by 2, that's actually an undefined value. If you remember the graph of the tangent function, if this is x equals pi divided by 2, then the graph of tangent looks something like this. There's an asymptote at that value of x at pi divided by 2, and so the tangent function is not defined at that value. And so it's an undefined value, but what would make this side of the equation an undefined value? All right, because we clearly can't solve tangent of pi divided by 2. We don't know what that is. However, remember that dividing by 0 would give you an undefined value, right? If x was equal to 0, it doesn't matter what the value of y would be. We would have y divided by 0, and dividing by 0 is always going to result in an undefined value. You're not allowed to divide by 0. And so what we can conclude here is that this statement is true. Tangent of pi divided by 2 is equal to y divided by x when x is equal to 0. Tangent of pi divided by 2 is undefined, which will be equal to this value when it is undefined, which occurs when x equals 0. So this is a little bit of a weird problem, but the final answer is that the equation in rectangular form will be x equals 0. That is the rectangular form of this polar equation. All right, next up we want to convert this polar equation to rectangular form. We have r equals secant theta divided by 3. Now, whenever you have a polar equation where you have r equals secant theta or r equals cosecant theta, what I recommend that you do is divide both sides by that trig function. So in this case, we want to divide both sides by secant theta. That is going to help you see how to use your conversion formulas to write this polar equation in rectangular form. So if we do that in this case, we'll have r times 1 divided by secant theta is equal to 1/3, right? If we divide both sides by secant theta, this secant theta will disappear. It will cancel out, which is why we only have 1/3. And then on this side of the equation, we have r divided by secant theta, but I decided to write it like this, r times 1 divided by secant theta, because that's going to help us see how to use one of our conversion formulas. Because what we can do next is rewrite 1 divided by secant theta using one of our trigonometric identities. We know that 1 divided by secant theta is the same as cosine theta. So we'll have r times cosine theta is equal to 1/3, and then what we have here, r times cosine theta, can be found within one of our conversion formulas. We have that x is equal to r times cosine theta, so we can replace r times cosine theta with x. So we'll have x is equal to 1/3, which is the rectangular form of this polar equation. All right, so here's our next example. Once again, we want to convert the polar equation to rectangular form. This time we have r equals 7 cosecant theta divided by 8. And so just like with our previous example, if you have r is equal to some constant times cosecant theta or secant theta, what you want to do is divide both sides by that trig function. This is only for cosecant and secant. All right, so let's do that in this case. If we divide both sides by cosecant theta, we'll have r times 1 divided by cosecant theta, and that will be equal to 7/8. Right? If we divide both sides by cosecant theta, this cosecant theta will be gone. It cancels out, and so we just have 7/8, and then we have r divided by cosecant theta, but once again, I decided to write it like this, so we can see how to rewrite this using one of our trig identities. We know that 1 divided by cosecant theta is the same as sine theta. So we'll have r times sine theta is equal to 7/8. And we know from one of our conversion formulas that r times sine theta is equal to y. So we can replace r times sine theta with y and have that y is equal to 7/8. And so y equals 7/8 is the rectangular form of this polar equation. All right, next up we have another polar equation that we want to convert to be in rectangular form. This time we have r equals theta, which looks to be a pretty basic polar equation, but the graph is actually pretty complex if you were to look at it. If you have some free time, I would recommend looking up the graph of r equals theta. It's actually pretty cool. But anyway, we want to convert this to rectangular form. And in order to do that in this case, what we want to do is figure out what r and theta would be equal to in terms of x and y. And we can do that by using these two formulas down here. We have r squared is equal to x squared plus y squared. This is an equation where we have r in terms of x and y. And then for this equation, tangent theta is equal to y divided by x. This is an equation with theta in terms of x and y. So what we want to do is solve for r and solve for theta in these equations, and then whatever they're equal to, replace them for r and theta in this equation. So let's start with the r squared equation. We know that r squared is equal to x squared plus y squared. If we want to solve for r, we can just take the square root of both sides of the equation. So we'll have r is equal to the square root of x squared plus y squared. So that's what r is equal to. We can replace r with this expression. But then for theta, we have this equation. So we'll have tangent theta is equal to y divided by x. To solve for theta, we can use the arctangent function. We can take the arctangent of both sides of the equation, and the arctangent function is the inverse tangent function. So the inverse tangent function will cancel out with this tangent function, right? Arctangent and tangent will cancel out, and that will give us theta is equal to arctangent of y divided by x. And so that's what theta is equal to in terms of x and y. So now, all we have to do is substitute both of these expressions into this equation. We'll have that r is equal to theta will be the square root of x squared plus y squared, and that will be equal to arctangent of y divided by x. And we're not going to try to simplify that at all. It's pretty ugly, pretty complex, so I'm going to leave it in this form, but that right there is the rectangular form of this polar equation. All right, so here's our next example. We want to convert this polar equation to rectangular form. We have r equals cotangent theta times cosecant theta. Now, if you remember from one of our previous examples, whenever you see cosecant theta within your polar equation, you want to divide both sides by cosecant theta. That actually will apply in this scenario as well. Even though it's being multiplied by cotangent theta, whenever you see cosecant, you should try dividing both sides by cosecant, because that will introduce the sine function to the other side of the equation, and you'll have r times sine. So let me show you what I mean. If we divide both sides by cosecant theta, we'll have r times 1 divided by cosecant theta, and that will be equal to cotangent theta. All right, so we divided both sides by cosecant, so this cosecant disappears, and now we have 1 divided by cosecant theta on this side of the equation. But using our trig identities, we know that 1 divided by cosecant theta is just sine theta. So we'll have r times sine theta is equal to cotangent theta. Okay, so now we have r times sine theta, and we know that that is equal to y, so we can rewrite that, and we'll have that y is equal to cotangent theta. But now how do we rewrite cotangent theta in terms of x and y? Well, if you look over at our conversion formulas here, we know that tangent theta is equal to y divided by x, but we also know that tangent theta is the reciprocal of cotangent theta, right? Tangent theta is equal to 1 divided by cotangent theta. So if tangent is the reciprocal of cotangent, then that would mean that cotangent is the reciprocal of tangent. So all we have to do to find cotangent theta in terms of x and y is find the reciprocal of what tangent is equal to. We can just flip the numerator and denominator of this fraction. So if tangent theta is equal to y divided by x, then cotangent theta will be equal to x divided by y. So we can replace cotangent theta in our equation with x divided by y. Okay, and so now our equation is in terms of x and y. Now let's just simplify it a little bit. If we multiply both sides by y, then we'll get our final answer that y squared is equal to x. That is the rectangular form of this polar equation. Okay, let's take a look at one more example of converting polar equations to rectangular form, and then we'll start looking at some examples of converting from rectangular equations to polar form. All right, so here's our last example for converting a polar equation to rectangular form. We have r equals 6 times sine theta plus 8 times cosine theta. Now, whenever you have a polar equation that involves sine or cosine or both of them added together, like we have in this case, what you want to do is multiply both sides of the polar equation by r. And what that's going to do is make it very easy to use our conversion formulas to convert this from being in polar form to rectangular form. And so let me show you what I mean. If we multiply both sides of the equation by r, we'll have r squared is equal to r times 6 times sine theta plus 8 times cosine theta. But now let's distribute this r through this quantity. We'll have r squared is equal to 6r times sine theta plus 8r times cosine theta. And now we can make some pretty simple substitutions. We know that r squared is equal to x squared plus y squared. So let's do that. We'll have x squared plus y squared, and that will be equal to 6r times sine theta plus 8r times cosine theta. And we know that r sine theta is equal to y, and r times cosine theta is equal to x. So we'll have 6y plus 8x. And now what we have here is this polar equation, but in rectangular form. Okay, and so that is the rectangular form of this polar equation. And so this was our last example for converting from polar equations to rectangular form. Now we're going to start looking at examples of converting from rectangular equations to polar form. And so let's start looking at those next. All right, so for this example, we want to convert the rectangular equation to polar form. and we have x equals negative 7. And so when you have a very simple rectangular equation like we have right here, where you just have x equals some constant, all you have to do to convert it to polar form is replace x with what it's equal to in terms of r and theta. We know that x is equal to r times cosine theta, so we can replace x with r times cosine theta. So we'll have that r times cosine theta is equal to negative 7. And then what we want to do is solve for r, and then our equation will be in polar form. So in order to solve for r, we need to divide both sides by cosine theta. And if we do that, we'll have r is equal to negative 7 times 1 divided by cosine theta. And we know that 1 divided by cosine theta is the same as secant theta. And so what we'll have here is that r is equal to negative 7 times secant theta. And that is the polar form of this rectangular equation. Okay, so basically what we did here is the reverse of what we did in one of our previous examples. You'll remember when we were converting from polar to rectangular, that when we had r is equal to some constant times secant, that we divided both sides by secant to introduce cosine, so that we would have r times cosine theta, which we could replace with x. All right, let's take a look at another example. Next up, we want to convert this rectangular equation to polar form. We have y equals the negative square root of 2. And this is very similar to our previous example. When you have a very simple rectangular equation where you just have y is equal to some constant, what you want to do is replace y with what it's equal to in terms of r and theta. We know that y is equal to r times sine theta, so we can replace y with r times sine theta. So if we do that, we'll have r times sine theta is equal to the negative square root of 2. And now what we want to do is solve for r, and then we will have our polar equation. So in order to solve for r, we need to divide both sides by sine theta. And so if we do that, we'll have that r is equal to the negative square root of 2 times 1 divided by sine theta. But remember, from your trig identities, that 1 divided by sine theta is the same as cosecant theta. So we'll have that r is equal to negative square root of 2 times cosecant theta. That is the polar form of this rectangular equation. All right, so next up we want to convert this rectangular equation to polar form. We have x equals y, and this is a pretty simple rectangular equation for us to convert to polar form. All we have to do in this case is replace x and y with what they're equal to in terms of r and theta. So we can replace x with r times cosine theta and replace y with r times sine theta. So if we do that, we'll have r times cosine theta is equal to r times sine theta. All right, and then typically our next step is to try and solve for r, but in this case we have r on both sides of the equation, so it's going to be canceled out of this equation, so it looks like in this case our polar equation, or the polar form of this rectangular equation, is going to only involve theta. And so what I'm going to do is divide both sides by r times cosine theta. And if we do that, we'll be dividing r times cosine theta by itself. So we'll have 1 is equal to r times sine theta divided by r times cosine theta. And now these r's will cancel out. R divided by r is just 1. And then sine theta divided by cosine theta, we can use one of our trig identities and rewrite that to be tangent theta. We know that sine divided by cosine is tangent. So we'll have 1 is equal to tangent theta. And now what we want to try to do is solve for theta. We don't have any r's in our equation anymore. So instead, we should try to solve for theta to get our polar equation. And the way we can solve for theta is to take the inverse tangent function of both sides, or the arctangent function. And if we do that, we'll have arctangent of 1 is equal to arctangent of tangent theta. But since they're inverse functions, arctangent and tangent, they're just going to cancel each other out and leave us with theta. So we'll have that that's equal to theta. All right, and then to simplify, arctangent of 1 is just equal to pi divided by 4. So our final polar equation is that theta is equal to pi divided by 4. Next up, we want to convert this rectangular equation to polar form. We have x squared plus y squared is equal to 20. Now, if you want to convert this to polar form, you might be tempted to right away replace x with r times cosine theta and y with r times sine theta, but there actually is a simpler way to do it. replacing x and y with those two expressions would work. You would get the correct polar equation, although it would require some extra work. But if you look at this other equation we have here, we know that r squared is equal to x squared plus y squared. So we can just replace x squared plus y squared with r squared. So we'll have r squared is equal to 20, and now we can just solve for r by taking the square root of both sides. And so we'll have r is equal to the square root of 20, but we can simplify the square root of 20. Remember that 20 is the same as 4 times 5, and so we can take the square root of 4, we know that that's 2, and so our polar equation will be that r is equal to 2 times the square root of 5. All right, and so that is the polar form of this rectangular equation. All right, so for our next example, we want to convert this rectangular equation to polar form, and we have x squared is equal to 8 times y. Now once again, just like with our previous example, you might be tempted to immediately replace x with r times cosine theta and y with r times sine theta, and that would work, but for this equation there is an easier way to go about converting it to polar form. What we can do is divide both sides by x. That will reduce this x squared to just be x, and then we'll have 8 times y divided by x, or 8 times y divided by x, right? So if we divide both sides by x, we'll have x is equal to 8 times y divided by x. Now the reason I did that is because then we don't have to square anything, and we know what y divided by x is equal to. Y divided by x is equal to tangent theta. So we can replace y divided by x with tangent theta and replace this x with r times cosine theta. So we'll have r times cosine theta is equal to 8 times tangent theta. And now all we have left to do is solve for r. And so if we divide both sides by cosine theta, we'll have that r is equal to 8 times tangent theta times 1 divided by cosine theta. All right, but 1 divided by cosine theta is the same as secant theta, and so our final answer is that r is equal to 8 times tangent theta times secant theta. That is the polar form of this rectangular equation. Okay, so if you ever see x squared is equal to some constant times y to the first power, or the reverse of that, y squared is equal to some constant times x, I would recommend that you divide both sides by whatever variable is being squared, and then either use tangent theta to replace y divided by x, or cotangent theta to replace x divided by y. It's going to make converting that rectangular equation to polar form a lot simpler. All right, let's look at another example. Okay, so next up we want to convert this rectangular equation to polar form. We have x times y is equal to 5. Now this one's going to be a little bit trickier than some of our previous examples. There's no easy way to rewrite x times y in terms of r and theta, so we're just going to have to replace x with r times cosine theta and y with r times sine theta, and then try to simplify from there. So what we'll have is r times cosine theta, that's replacing x, and that will be multiplied by r times sine theta, that's replacing y, and that will be equal to 5. All right, now we do have two of these r's here, so if we combine them, we will have r squared, and then that's multiplied by cosine theta times sine theta, and that's equal to 5. All right, so now at this point, our goal should be to try to solve for r. So I think the first thing that we can do to accomplish that is divide both sides by cosine theta times sine theta. So if we do that, we'll have r squared is equal to 5 divided by cosine theta times sine theta. And now what we can do is take the square root of both sides, and we will have solved for r. So if we do that, we will have r is equal to the square root of 5 divided by cosine theta times sine theta. Okay, and so this would be an acceptable answer for the polar form of this rectangular equation, but if you are familiar with your trigonometric identities, you can simplify this further into a nicer form. In particular, the trig identity that we can use in this case is that 2 times cosine theta times sine theta is equal to sine of 2 theta. All right, we have cosine theta times sine theta in the denominator here, and so we could rewrite that using this identity. just notice that we don't have this 2 multiplied by both of those functions. So if we divide both sides of this equation by 2, then what we would have is cosine theta times sine theta is equal to 1/2 times sine of 2 theta. So what we can do is replace cosine theta times sine theta with 1/2 times sine of 2 theta. So if we do that, we'll have that r is equal to the square root of 5 divided by 1/2 times sine of 2 theta. All right, now that might look a little bit more complicated than what we had before, but now what we can do is move this trig function to the numerator by remembering that 1 divided by sine is equal to cosecant. So we can have cosecant of 2 theta in the numerator here times 5. And then remember that dividing by a fraction is the same as multiplying by the reciprocal of that fraction. So instead of dividing by 1/2, we can multiply 5 by 2. So what we'll have is that r is equal to the square root of 2 times 5 times cosecant of 2 theta. All right, we just moved sine of 2 theta to the numerator, which turns it into cosecant. And then instead of dividing by 1/2, we multiplied by 2. All right, and then if we simplify, we will have that r is equal to the square root of 10 times cosecant of 2 theta. That is the most simplified form of the polar equation that corresponds to this rectangular equation. All right, so you could have left it in this form right here, but if you do know your trig identities pretty well, you can rewrite it into this nicer form. Next up, we want to convert this rectangular equation to polar form. We have x minus 2 quantity squared plus y squared equals 4. Now, in order to rewrite this in polar form, the first thing that I would recommend that you do is expand this squared quantity. Right? Either way, we're going to have to square this quantity anyway to solve for r in our polar equation. And so let's just get it out of the way first before we make any substitutions. So let's square this quantity, let's expand all of our terms, and then we'll work on replacing x and y with what they're equal to in terms of r and theta. So in order to square this quantity quickly, what I'm going to do is use a little trick. I'm going to square the first term, then we'll add that to these two terms multiplied together, multiplied by 2, and then we'll add that to the last term squared. So what we'll have is x squared, that's the first term squared, and then we'll have negative 2 times x, that's a negative 2x times 2, so we'll have negative 4x, and then we'll add that to negative 2 squared. And negative 2 squared is positive 4. So now we have expanded this quantity. We have x squared minus 4x plus 4. Now let's write the rest of our equation. We have plus y squared is equal to 4. All right, now notice that we have 4 on both sides of the equation. So if we subtract 4 from both sides of the equation, these 4's will disappear. So what we really have here is x squared minus 4x plus y squared equals 0. Okay, but now, before we make any substitutions here, because you might be tempted to just replace each of these x's with r times cosine theta, and then this y with r times sine theta, notice that we have an x squared and a y squared. If we were to reorder our terms here, we would have x squared plus y squared minus 4x equals 0. We can replace this x squared plus y squared with r squared. R squared is equal to x squared plus y squared. That's always going to be an easier substitution than replacing x and y with r cosine theta and r sine theta. All right, so we can replace that with r squared. So I'll do that. We'll have r squared minus 4 times x, but we can replace x with r times cosine theta. So I'll write that in. We'll have r times cosine theta, and that is equal to 0. Okay, now we're not done yet. We need to solve for r. So the first thing I'm going to do is add 4r cosine theta to both sides of the equation. And if we do that, we'll have r squared is equal to 4 times r cosine theta. And now we can divide both sides by r. And if we do that, we will get our final answer that the polar form of this equation is r is equal to 4 times cosine theta. That right there is the polar form of this rectangular equation. Okay, so next up we want to convert this rectangular equation to polar form. We have 3x squared plus 2y squared is equal to 8. Now initially with this rectangular equation, it might look like you want to use r squared is equal to x squared plus y squared because we have x squared and y squared, but their coefficients are not 1. We have 3 and 2, and they're also not the same coefficient. If they were the same coefficient, then we could just pull that out and then replace x squared plus y squared with r squared. But since they're different, that makes this a much trickier rectangular equation to convert to polar form. So what we actually have to do in this case is replace x and y with what they are equal to with r cosine theta and r sine theta. So if we do that, we will have 3 times r cosine theta squared plus 2 times r sine theta squared is equal to 8. And now what we want to do is square each of these quantities. We'll square r and square cosine and square this r and square sine. So we'll have 3 times r squared times cosine squared theta plus 2 times r squared times sine squared theta, and that's equal to 8. Okay, and now remember, our end goal here is to solve for r. So if we can isolate r in any way, we should try to do that. In this case, I see that both of these terms have a common factor of r squared. So let's pull r squared out of those terms, and we'll have r squared times 3 times cosine squared theta plus 2 times sine squared theta, and that's still equal to 8. And now what we can do is divide both sides of this equation by this big quantity to isolate r squared. And then we will be able to take the square root of both sides to solve for r. So if we do that, we'll have r squared is equal to 8 divided by 3 times cosine squared theta plus 2 times sine squared theta. And now we can take the square root of both sides to solve for r. And so if we do that, we will have that r is equal to the square root of 8 divided by 3 times cosine squared theta plus 2 times sine squared theta. Okay? And so that's the final answer. It's not a very nice answer. It's pretty ugly, but this is the polar form of this rectangular equation. As far as I'm aware, there's not any trig identities that will make this simpler to look at, and so it's okay to leave it in this form. All right, and so let's take a look at one more example of converting from a rectangular equation to a polar equation. All right, so here's our final example. We want to convert this rectangular equation to polar form, and this looks to be a pretty complicated rectangular equation, but it will simplify nicely. And the first thing that I notice is that we have x squared plus y squared, and both of those terms are being squared. We can replace x squared plus y squared with r squared. And so I'll do that. We'll have r squared squared, and then we have minus 16 times the quantity x squared minus y squared. Now don't make the mistake of replacing x squared minus y squared with r squared. That's not equal to r squared. R squared is equal to x squared plus y squared, not minus. So there's no easy way to rewrite x squared minus y squared. We're going to have to replace x with r times cosine theta and y with r times sine theta. So we're going to have minus 16 times r times cosine theta squared minus r times sine theta squared, and that's equal to 0. All right, so if we simplify, r squared squared will be r to the 4th power, right? We can simplify this by multiplying those exponents. So we'll have r to the 4th power minus 16 times this quantity squared minus this quantity squared. So we'll have r squared times cosine squared theta minus r squared times sine squared theta, and that's equal to 0. Okay, now the next thing I'm going to do is distribute this negative 16 through this quantity. We'll multiply it by both of those terms. So we'll have r to the 4th power minus 16 times r squared times cosine squared theta, and then negative 16 times this term, which is negative, will become positive. Those two negatives will cancel out. So we'll have plus 16r squared times sine squared theta, and that will be equal to 0. Okay, and now what I'm going to do is move these two terms to the other side of the equation so that we can isolate r to the 4th power. And so if we do that, we'll have r to the 4th power is equal to 16r squared times cosine squared theta minus 16r squared times sine squared theta. All right, since we're moving these two terms to the other side of the equation, we added 16r squared cosine squared theta. so that's why it's positive, and we subtracted this term, so that's why we have minus 16r squared times sine squared theta. All right, and now the next thing that we can do is pull out a common factor out of these two terms of 16 times r squared, right? We have 16r squared here and 16r squared here. So if we pull that out, we'll have r to the fourth power is equal to 16r squared times cosine squared theta minus sine squared theta. All right, and now what we can do to simplify further is divide both sides by r squared. That will cancel out with this r squared, and this r to the fourth power will be reduced to just be r squared. So what we'll have is r squared is equal to 16 times cosine squared theta minus sine squared theta. All right, we just divided both sides by r squared, so this r to the fourth power became r squared, and on this side of the equation, we just have 16 times cosine squared theta minus sine squared theta. All right, now at this point, you could solve for r by taking the square root of both sides, but before we do that, we can simplify this expression further by using a trig identity. Specifically, there's a trig identity for cosine squared theta minus sine squared theta. We know that cosine squared theta minus sine squared theta is equal to cosine of 2 theta. That's one of our double angle identities for cosine. So we can replace cosine squared theta minus sine squared theta with cosine of 2 theta. And so if we do that and take the square root of both sides at the same time, we'll have that r is equal to the square root of 16 times cosine of 2 theta. All right, and then one more step to complete our answer. All we have to do is simplify the square root of 16. That's equal to 4. So we can just have the square root around cosine of 2 theta and have our final answer that r is equal to 4 times the square root of cosine of 2 theta. And that is the final answer. This is the polar form of this rectangular equation. All right, and so with that, this was the last example for this video. So if you have any questions, feel free to leave those in the comments. But if you don't have any questions, this is all I had for now. So I will see you next time.